Hi, I'm an old guy and I do maths, and today we're looking at a simple probability density function. If you don't know what a probability density function is, there's a video in the playlist explaining what they are. Have a look at that before you get too far into these. Now, this is a very simple probability density function, and it's slightly unusual in that it's not a curve, although an old maths teacher of mine would tell me that a straight line is merely a straight curve, and there is something to that. Anyway, let's just explain what's going on here. So this is the function, and you'll see it's composed of a couple of parts. This is not all that unusual. You'll have seen this with other types of functions, this sort of notation, but let's get into it. So there's a function y equals 2x, and that exists between 0 and 1, and I've done a rough sketch of it here. And it would have, normally it would have, if we were describing it fully, it would have these little open circles on it to say that it was less than or greater than. Okay, the other part of the function is to the left of it and to the right of it, and what I've tried to show here, I've tried to show that the function is equal to 0 in these parts, but I've had, of course, to raise this a tiny bit so that you can see the red against the blue. But the idea is that there is no area between the function in this area and the blue line. The function is equal to 0 at 1 and beyond, and it's equal to 0 at 0 and beyond. Okay, so really the only area that exists is under this line here between 0 and 1. And this is our probability density function. The whole thing is, but this is the area that we're concerned with. Now, a thing to note, if we were to figure out the area that's under this part of the function, so let's just pretend that we've got ourselves a triangle here. It's very easy to do. The base is 1, the height is 2, we'll say, because you'll note that it approaches but does not equal these values. And so the area under this curve, height times base divided by 2, the height is 2, is 1. And that's typical of probability density functions. If you've got a probability density function with a value of more than 1, you've got trouble, because whatever it is, it's not a probability density function. Right, so how would we normally go about finding this? Well, normally what we would do is we would integrate this, and we would work out its value as a definite integral between 0 and 1. So we'll just do that quickly. So the integral of this will be that. And if we put 1 into this, what we get is the 2's cancel. So we get x squared, which means we get 1 squared, which gives us 1. If we put 0 into this, of course, we get 0. So effectively, all we have to do is insert the 1. If this is a little bit of a surprise, have a look at my videos on definite integrals. Sorry, that should be 0. You'll understand what it is I've just done. But effectively, I've found the area under this curve. Now, if we were interested in the probabilities between 0 and a half, we would make this 0 and this 0.5. So really that's all I wanted to show you in this video. It is probably the simplest probability density function you're going to see. All of the others you'll see will probably involve some sort of curve. And the key things to take away are that the area under here should not exceed 1, and that in order to discover the probabilities we need to find the definite integral of the function and put in whatever the parameters are that we're looking for. Okay, well, thank you for watching. I hope you found this useful. If you did, please like and subscribe, and I'll see you next time. Bye.